Welcome everyone. This is the final one in our template series. Some of you may have joined us for the other two. This one's different to the others in that anyone can use it with any Unity license, a free Unity license. You don't need to be part of industry. Just while we go, if you have any questions, please do put them in the Q&A tab rather than the chat, and then we'll get to them as we go, and there'll be some Q&A time at the end, I think, if we manage it. Yeah, otherwise, I'll hand you straight over to Jack.
Very good. Thanks for the introduction, and thanks for everybody joining. Really good to have lots of people interested in this topic, IoT, the Internet of Things, as we call it. So we've created a sample project. We've made it available, as you're going to see, and we're going to take you through how to make it set up, how to use it, and take it a little bit further forward. A couple of intros of you two presenters today. So myself, Jack Strongitharm. I'm based in the UK. I'm a solution architect. So I focus on everything that's industry within Europe, Middle East, and Africa. And I've been a civil engineer in my past. I'm not a developer, so excuse the code that you'll see later from me because I can't write any. But I am joined with Daniel Bearwith, who's based in Berlin. Daniel, maybe you just give us a short intro about yourself.
Yeah, sure. Happy to meet you all. I basically work alongside with Jack in the same team. I'm on the technical side, software engineer background. And while talking to a lot of Unity users, we actually noticed that people seem to struggle figuring out how to connect external systems like IoT backends. And this is one of the motivations why we created this small sample project, just to give you an easy start into this IoT domain. And as you will see later in the webinar, we will start on the technical level and then show an actual implementation based on the technical foundation. So let's continue, Jack.
Okay, so yeah, here's a rundown of where we're going to go. So yeah, the main focus is the IoT sample project. Hopefully you've seen it advertised in LinkedIn and other different places, maybe how you got to this webinar as well. So Daniel's going to focus on that. He's the main creator of this. I just gave him lots of issues to fix. And then we also created a little sample project, which is available as part of the project. And also we do have it hosted on WebGL as well. So you can give that a try without downloading it. And then you're going to get me with Home Assistant and Zigbee devices. So I've taken the project that Daniel provided and I've hacked around it a little bit. So not everything that's in the project by default is what I've used. I've added to it. We're going to look to maybe do a version 2 fairly soon. But I wanted to show you what you could do with it pretty quickly, make it work at home, get some devices that you may already have, and start linking that to Unity and creating some cool things, even at home, before you even bring it to work. So with that, I'm going to hand over to Daniel and let you take over the share.
Yep. Let's continue. It's the same slide deck. Next slide. It's about the IoT sample project. I quickly want to walk you through how to actually set up a device twin in Unity and set up a connection to either the real telemetry data coming from the field device or simulated telemetry data. And this is also the main theme of this webinar, showing you how to use a Unity-powered application in conjunction with an external system that is delivering telemetry data from devices. And as previously mentioned, it's a very basic project, not to confuse anyone, with a simple connection interfaces to MQTT or an Azure backend, alongside with some reference scripts that allow you to basically seamlessly distribute the incoming messages to the actual device that should expose them. And this is what we want to show you. As Jack mentioned, you can access the sample project on our asset store. So feel free to scan the link here. We also will share it in the meeting chat, so you can access it right away. something I want to note, and we will go into the template or into the project in a minute. Even though it's noted, it does only support the URP pipeline. This is mainly focused on the building sample that we included in the project. The communication interfaces, they are actually render pipeline independent. And something that I want to highlight, we do everything live, so bear with us if something is not working right away. It's not a pre-recorded video. And with this one, I will pause the presentation and we'll go into the project to show you what you actually get. Let me make this a bit larger. So what you see here is a simple empty Unity project. I already loaded the, the sample from our asset store. And here you see a sample scene, nothing added yet. And I want to quickly walk you through the most basic way of setting up a device twin in Unity and then sending data into the Unity application. And what you can do is simply create an empty game object, in this case a simple cube, and let's call it simple IoT device. And in order to create or map this one into the real IoT counterpart, we created a couple of scripts that we will show later to you. What you can do is use the generic one. It's really just a basic one that exposes messages whenever a message arrives with a certain device ID. And besides that, there's not much functionality included apart from basically linking a simple context UI that you can actually create a contextualized visualization. In this case, it's a simple 2D UI where the telemetry data get exposed. At a later stage, when we show the building sample, you will also see other approaches of creating visualizations based on the incoming data. Could be like simple color schemes or heat maps that get generated. And for our example, we give this a simple name and call it simple IoT device. And what we also need to do is add a hotspot component. So at the end, once we go into play mode, we are actually able to click on the hotspot and expose the telemetry information. So this is here a hotspot prefab that we created for you. It's just a simple script that triggers based on the interaction and then forwards the event to a UI system. So what we need to add here is an event handler, the event system, and then we created a simple telemetry canvas prefab. It's basically a canvas that contains a context window. And if I show the context window, you will see it's basically a simple empty context window without much intelligence, which just has a list and can basically expose all the incoming data. So let's disable this for now. So we have our IoT device set up. Now the interesting part is how to actually set up the connection to an external system. And in this case, we start with a simple MQTT communication. We created a prefab. It's based on the open source M2 MQTT library. And what you see here is some fields that you can fill in. They basically point to the remote IoT backend. And that's about all you need to do. You just need to know where's the endpoint that I want to connect to. And that's all you need to enter here. The whole message distribution internally is already handled by the underlying framework. And then based on the device ID mapping, each device is in charge of representing the incoming data based on the device type. So what we can do here now is add a simple communication interface. I have an MQTT mosquito system running locally on a different machine. So that's why I enter here my local IP endpoint. And I also add the broker port. And then the interesting part is also setting up the channels. So you could, in theory, also add multiple connector interfaces and subscribe to different topics. In this case, we subscribe to a generic topic, something that you can freely configure. We just because it's a part of our IoT building demo, we decided to leave it with the building sensors updates. And at the later stage, you will also see why. And then you need to enter like a simple username password communication. So if we go into play mode, we should now hopefully see that our system is able to connect to the remote IoT backbone. That's what we see here. And what I can do now, let me move this a bit. We can start a script that is simulating the telemetry data. In this case, it's a simple script that just sends a single message. And I've already prepared the script. So it's a Python script that you can run with the Python command and then send single message to MQTT. That should it be. Yeah. So let me show you the script. Sorry, it's this one here, so that you know what I'm doing. The script is also part of the project, and it's just a simple device message here. And each time we run the script, we basically open an MQTT client, talk to the remote system, and publish a message on the defined channel. In this case, this topic here, building sensor updates. And on the Unity side, we basically, as we already set up our system, we basically listen to this topic. That's what we did here in this generic device component, where we defined the device ID, which is the same as the device ID here, that we create the sensor message for. And in our MQTT connector script, we basically set up the same credentials as here, another client, but in this case, it's a client that is currently just subscribing to messages. At a later stage, you will see the bidirectional communication in a sample that Jack prepared, where you can actually also send commands from Unity to the real device to actually control the physical device. So now, as we already sent the message, it's there, so I can now click here and expose it. But I could also say, I modify the content here and say it's like new message content. I save, then I go into the Python script and send the message again. And you see basically instantly it's also available here. The UI gets updated and you can now start working with the message. And this was one of the main objectives that we had in mind when we created the sample project, giving you like a technical foundation as a start so that you can focus actually on the use case implementation and don't need to spend a lot of time on figuring out what is the ideal way of sending messages internally to all the game objects that you have in the scene, and then how to pass the JSON information coming from an external system. So this is all abstracted. And I can also quickly show you the script. As mentioned, it's this generic device. It's a very basic script. It does not have a lot of functionality embedded. All it does is, and that's what you can also do if you want to create your own custom device, you basically just inherit from the base device, and then you need to subscribe to the message bus, and then you are able to basically register the message handler, and whenever a message arrives, you can work with it. So this is what we saw now, like the log that you saw on the console, and also the message that we exposed in the user interface. So this is all already available as a starting point. What we can do now is think about a different scenario where we do not talk to a local broker system, but rather to one that is maybe running in the cloud somewhere. And this is what I want to show you now. So let's pause this for a moment. Go back in the browser. For the cloud sample, we decided to use this HiveMQ system as a demo, which is quite handy. So let's simply take the same IoT connector prefab. I move this over here so we can see it better. And what we need to do now is replace the broker endpoint because we want to talk to another one. And in this case, it's broker URL. So that's the broker URL that allows me to get all messages that get sent by the HiveMQ system, which is running in the cloud. That's also the port. And this is using encrypted communication. So we also activate the secure checkbox here. And now we should be ready to go. and should be able to send this or talk to the same device, but in this case from a different MQTT system. So let's go into play mode again and see if it works. I know it didn't work because I didn't update the passcode, the username combination. So in this case, it's Unity 2025, and I think with capital. And don't worry, we will delete this instance after the webinar, but feel free to copy this one and test it yourself while it's running. So yeah, now we are basically able to connect to this remote system. I can expose user interface now. So currently no message arrived, but if I go here into, I already prepared one, into this simple web client to send message, I'm now able to send a message and it will be instantly here. So without doing a lot of changes in Unity itself, apart from toggling the IoT backbone, we are still able to work with it as in the previous instance. And in fact, we could also think of scenarios where you have devices represented in Unity that get actually information from different backbones. And that's what you could do now also. So you could basically create multiple connection interfaces where one is getting information from a specific broker system, like in self-hosted MQTT service. Maybe another one is getting messages from an Azure IoT Hub or an AWS system. So this is all available with the sample project. And by speaking from Azure, I can also show you quickly how to change the communication interface to an Azure one. And this is done by a different prefab. So I disable the MQTT connector prefab for now. We have another one. It's in prefab. IoT Hub plugins. Yeah, in here. So this one, and this maybe is also a good way of opening the Azure message provider. So, and in comparison, we can also open the MQTT message provider. So you can basically see both systems inherit from the same base message provider that encapsulates basically everything that both communication interfaces share. And then we have specific implementations, like this one is specifically aimed for the Azure communication, where we talk to an Azure endpoint that allows us to get all the informations that get aggregated on this specific IoT Hub running on Azure by all the different devices without having a direct communication to the device itself. So here we just enter the Azure endpoint, and this is what I can show you now. I'm not sure how many of you use the Microsoft Azure portal and the IoT Hub system. I don't want to confuse you too much, but there is like a device management system where you see all different IoT devices that are set up. And then there is the Azure IoT Hub endpoint that we also use to get the information that gets sent by the field devices to this Hub instance here. So what I did now is I copied this endpoint string and will enter this one in here in the Event Hub endpoint. And now the system will basically connect to this endpoint and tell me what messages maybe previously have been sent or what messages get sent now. For the IoT or the simple IoT device itself, I don't do anything. So this remains the same. All I did is I populated this Azure connector here. So now if I go into play mode again, I see the messages that have been sent previously. So let's clear the console and go into my simulator script. I created a simple simulator script to send single messages to the IoT Hub. So let's find this one. To for IoT Hub. Yeah. So this now is sending a simple message to the IoT Hub with a certain timestamp, and this should all match. Let me move this over here so we can see it a bit better. So if I open this simulator script, in this case this one here, you can see I already prepared the Python side. And as mentioned, the Python scripts are also part of the sample project, so you can easily replicate what we are showing here. And this is, I'm not sure if you are a Python friend or not, but once we run the script, we enter the main function here and create a simple client based on using the connection string. And this client is then used to send or send a simulated message, this one here. So I could now, hello, this is a device message. Hello, this is a new device message. And if I run it again, you will basically see it has been updated. And our idea is that you use this as a jump board to start with an easy way of communicating to all the different devices. So that's regarding the simple device setup. Of course, you can go to a more advanced way of connecting the devices, but also creating the visualizations. And that's what you see in here in our sample project. In our scene here, let me load the building scene, this one here, and go real quick into the presentation mode. So we went through this 3 steps, basically setting up an IoT device, connecting to an MQTT system, and then we showed how easy it is actually to also talk to an Azure IoT Hub. And again, if you want to scan it, otherwise we go now into the next section where we show the IoT sample project and also show you a different way than compared to the previous one where we manually selected the device and added the script to a more automated way, which is especially handy for large data sets. Let's assume you have a BIM model with a lot of smart devices embedded. You don't want to go by hand through the building model and assign all the scripts. That's why we created a simple device locator method that allows you to locate IoT devices by a naming convention, for example, but you could also easily extend this to extract the device representation based on the metadata contained in the building model or some other intelligent logic. And that's what we want to show you now. So let's end the slide deck for a moment and then go into the building model. I will make this a bit bigger. So currently the device connectors are disabled. If you want to test it, you can test it using a simple script that creates the device telemetry information directly inside Unity. But that's not what we actually want to show you. And currently nothing is running because they are disabled. So if you want to simulate the device information, you can, for example, it's already enabled. You can enable this one, and then there is like a checkbox here where you can say simulate events. And as mentioned, it's a simple script that we created that actually has the device telemetry data embedded in the script. So nothing too fancy. And now we enabled the MQTT interface. If we go into play mode, we will now actually see that the different IoT devices inside the building actually change their state based on the simulated telemetry data. So this is what we see here. And now we can basically select also all the different devices and we get them exposed here. And maybe you also notice that the user interface is a bit more sophisticated. We added different devices, rather simple ones. One is an occupancy representation. The other one is like one that represents heating, air condition and ventilation systems. or one that is showing the occupancy or level on an aggregated level where we show the occupancy for the room rather than the individual seating area. And the bottom part here actually shows you also the data that gets currently simulated, or if you connect to the real system, the real data coming from the remote system. That's what we prepared as a simple sample. And as mentioned, the user interface here is a bit more sophisticated, where we did a simple key value mapping. In contrast to the generic context window, we just add for each item that we receive, we add a new line here. But in this case, we actually map the value that is incoming to the key that we prepared in the UI interface so that we can create. In this case, it's just simple icons, but Jack will show you a more fancy one where we actually also show like simple heat maps or a gout that is moving. So in this case now, if I go onto the cloud version, we will see the data is stopping because we did not enter any MQTT endpoint information, or we already did, but the script is not running. So what I can do now is run the script, and then you will see that the data or that the devices change their state, but in this case, based on the remotely sent data from our MQTT broker system. And for this one, we also prepared a simple script. It's the Python and then MQTT building simulator. And now you see basically the system is running again and is exposing the incoming messages that we sent from the Python side, which currently simulates the field devices because we, in this simple demo, don't have the physical devices that we can talk to. But assuming you had the physical devices, you would now be able to switch between simulating data inside Unity or exposing the real-world data that is arriving inside Unity. So if I stop now the simulator, also the update gets stopped here. I can start it again, and we will see the data is coming or arriving again inside. And at any time, we can also switch to the simulator mode. So this is in case you already opened the project and you wondered what this functionality is for. So this is basically allowing you to simulate data that is inside Unity or swap to the actual broker system. And you will also see each time we select the different modes, the MQTT client either gets disconnected or gets connected. For the device localization, as mentioned, for a real-world scenario, we don't think someone would sit manually and add the device information, like for example, for this air handling unit. You wouldn't actually go through this whole hierarchy of this office, but rather define some kind of logic where you are able to identify the items based on some convention. And that's what we did with this IoT devices prefab here, where we said we think a good start of automating the device identification in a building model is selecting the model as a root node and then go through the whole hierarchy and identify the different devices that you want actually work with. And let's take, for example, the lunch table here. It's a simple scriptable object where we defined a device name tag and also assigned a device type that at the end defines on how the information gets exposed, either as like a heat map or some coloring or maybe a particle system. But again, it's all meant to be extended and just to be understood as a basic starting point. So now if I go into play mode again, you will see that the list gets here populated based on the available devices inside the model that get identified. So now here you see, if I scroll down a bit, you see all the different devices in the building that we identified. And if I click on one, you see it gets automatically assigned the device script. In this case, it's a thermo device, or maybe select a different one. Yeah, the lunch table, which is an occupancy sensor that just changes color based on its state, whether it's free or red or occupied, it changes to green or red. And for all the devices, we prepared simple context windows as a starting point, and you can find them here. They are, as mentioned, just to be like understood as a starting point. So I could now click on here this context UI. And this one here gets populated based on the actual device. So if I select this lunch table and go into the occupancy sensor script, we can follow the route and assume we have a message that arrived that we want to export in this UI. You can see here there's an expose message function, and we can go to the definition in this case. And here it does the key value mapping and adds basically the key value pair to the context UI. This is what you see here. And in our script, for example, here for this context window, we have a simple enhanced context window that implements or inherits from the context window that we used in the first section, where we just expose generic device information, and gets a step further where we populate the list and add icons and then map basically the value that is incoming from the remote system to the correct entry. And with this, maybe I hand it over back to Jack so he can go and show you what else you can do with it. And if we have time, we can go into the project itself at a later stage, I think.
Great stuff. Just checking you can see my screen share, yeah?
Yep.
Good. Okay, I'm not turning the video on yet because I will come back to that quite soon. Also, there's a couple of questions in the box. I think we'll address them live when we get to the end of this section as well. So keep on your mind thoughts, we will answer them. Okay, so obviously what Daniel's shown you is in the sample project. Everything works fully as he's demonstrated there. So if you just need to watch back this webinar, obviously step by step, you should be able to recreate what's in there. And as he mentioned, the Python scripts are in there as well, and obviously you can change those to suit what you want to simulate. But I also wanted to show you something with actual devices on my desk, as you'll soon see them, because I think it's, you know, if you're going to build a prototype, a POC, you know, you may not always have access to specialist hardware and devices in building, but also we are showing more building related type stuff here, but it could be a machine, it could be any kind of electrical equipment that could share its information in one of these kind of forms. So this sample project should be able to be used across many different use cases, not just what you've seen on this webinar. So, but it is good to try something at home. So what I'm going to show you now is something that is very popular, something called Home Assistant. So you may already have some smart devices at home, but a lot of hobbyist enthusiasts use this Home Assistant setup because you can link many different devices to it. And I looked into this to how we could use this with our IoT project, and it has an MQTT broker, so it's something you can install there. You can run this on a Raspberry Pi or a virtual machine on the PC. So I've actually got it on a Raspberry Pi, but I've tried it on a VM and that's fine too. So really easy to install. Lots of videos on YouTube on how to do it. And then I found with Zigbee devices, so these are devices that I bought on Amazon and other good shops like that. There was a setup here again, totally included with Home Assistant, a Zigbee to MQTT service. So it means all devices linked through this method would be able to be shared to an MQTT broker, which is on Home Assistant as well. So even better. So these are the things I've bought, and then you're going to see them in action as well. In fact, let's turn on the video. So change the screen. It looks different now. This is called a Sonoff broadcaster. So that is what you plug into either your Raspberry Pi or VM, and that's what it's a receiver of all these devices that we plug into. You can see the bulb. So I've just got one plugged in for now. A couple of smart plugs, temperature gauge, and also I haven't put an image on here, occupancy sensor. So that's currently switched over, so you can see the difference. And you see that I've got all these devices linked with nice friendly names as well, which means it's easy to understand. Another great thing to download as well, this is open source, free little tool called MQTT Explorer. And this is really good. Even before you start doing anything with Unity, you can see the information that's coming out, and you see it's in the form of a JSON type formatting. So you can see what values come out of each device, so you know what you can talk to. And you can see obviously the topics, which you've already seen with Daniel's stuff. So let's go one step further. So I'll come out of here, we'll go on Home Assistant. So before I use anything with Unity, well, let's switch some things on and off so you can see how this works. I can come in here and change the color, for example, and power. Yeah, so all quite nice. I'll turn it down a bit because it's going into my eyes. I also can switch on the little fan as well. It's just a cheap desktop fan, but you get the idea. So all this is running just straight on Home Assistant. If I go on Zigbee to MQTT, you can see where they're all set up, and you can click on any of these as well. So again, many videos on YouTube on how to set these things up, but that's how I've got it working. We come to Unity now, so I've built a different scene here, but using the same framework that is provided with the sample project. So I've got my broker endpoint, so it's just the IP address. I've made the Raspberry Pi a fixed IP, which kind of helps as well. Port, and then I'm looking at the Zigbee to MQTT topic, and then I've got a wildcard here to find everything that comes through there. Username and password, nothing magic there. It's all on my desk. And let's run the demo, and then I'll explain a little bit more of what I've done in here. So let's press go. Okay. So simple camera controller, etc. So I'm going to press the buttons on here this time. So can turn on the light, and you see the temperatures showing now as well, based on what values are here. Can turn on the fan as well. And I've also put a thing to show the actual information that comes through from each device as well. Yeah, so that's actually controlling my fan. And then a bit of fun, turn over the occupancy. And then I found this cool VFX sample just to put something fun in there, just because it's a bit more advanced than what you get on Home Assistant panels. So again, these things are moving. And then, well, what else could we do? So I'm going to turn that off because it gets a bit heavy. I also can go the other way. So using Unity, I've tweaked the system that Daniel provided in there to go backwards as well. So it's bi-directional now, and also color controllable. So the only thing I found was with the color, it had to be in this format called XY. So that's why when I move the sliders, it kind of corrects itself a little bit to find a suitable color. And then let's breathe on the thermostat. This one might take a few moments to update. It's a cheating way to get it hotter and higher humidity. And yeah, I can turn off the fan as well. But yeah, bi-directional, which is quite cool. So I don't know if that's going to update in time. But yeah, so as well as information being communicated inwards, I'm also sending it and publishing it out in exactly the same format as we receive it back. So then it works with Home Assistant. And again, if I go to Home Assistant as well, we can turn things on and off through here as well. Just the same. And we can go in the color chart, can make it brighter, and we can change all the colors here as we see as well. Yeah, so control it anywhere, which is what we wish for. That didn't update. Maybe I didn't breathe on it hard enough, but it will also change its color based on humidity and temperature if it's too hot. See, it's quite warm in my room. Don't have air conditioning in the UK. So just to give you a quick rundown of what's in here that I've added extra. So I added an IoT manager script. So I won't go through the code because I have no clue how I did it. I used AI to take the scripts that Daniel made, fed that in, and then asked for what I wanted, and then it came out with all this amazing stuff. Daniel probably hate looking at this afterwards, but hey ho. But I did this like yesterday, so it doesn't take long to make some adjustments to make it work the way you wish it. So here I'm plugging into those friendly names from Home Assistant that I've given it. So Smart Plug 2 and 1. My smart plug is this one for the light. I'll turn that off as well. And here I'm also able to pick apart from the activity that comes through to just pick the state. In this case, I wanted the state of showing it on and off. Yeah, so that state's updated here. I plug it in a text target as well for that one too. And that's about it for that one. I also can plug in other parts. Let's scroll a bit further down. Let's have a look at the bulb. So again, picking up the bulb separate to the plug. And again, looking for that. And then temperature one's got the most complexity to it because I've also added a slider. So this is a slider, this chart that we see here, the gauge kind of idea. And if I've given it a bit more heat, it would change its temperature based on a range that I set and change its color. And same for humidity, that definitely should have gone up because that's, increased the dampness to it. And you see I can also plug in the messages for each as well. And same on plugs, and occupancy is literally just turning on and off a game object. Yeah, so that's all that one's doing, is turning that thing on and off as well. The other part I did was to control the color. So again, link to the smart bulb _1, and that's its command topic as well. And here I'm linked to two standard point lights, one on the bulb and one on the Unity logo. I'm also linked to the material that's assigned, so standard lit material, URP material, so nothing advanced there because it's me that's doing this, remember. The slider controls, and of course the device manager. So it's all linked together quite nicely. And that's about it really. And then the two work. So one of the couple of considerations is out the box Home Assistant, its formatting. In fact, it's good to show it on this other little application. Where is it gone? Here. If we look at any of these feeds, it doesn't give a device ID. So one thing I read, but I've not implemented myself, is you can alter the YAML file of Home Assistant and you can add a device ID, so you can hard code and change the JSON structure a little bit. And if you do that, the sample project would work straight away because it needs that device ID for it to pick it apart separately. But what I did was made a change to read the subtopic as the device ID and also made it bidirectional. So those are a couple of changes I made. Hopefully it was of interest, and I'll take it back to questions, but hopefully what we've shown you today is useful, gets you inspired to have a go yourself, try the sample project as it is and extend it. If you're a coder, you can definitely take this further or throw it into AI and get that to help you as well. But we will look to maybe include some of what I've done here into the next update on the asset store as we move back. So with that, Daniel, was there any questions in the Q&A that maybe you are more qualified to answer?
Yeah, absolutely. There were a couple of questions. The first one that we can follow up on is the question regarding the supported platforms. So we are using an open source library that for the MQTT communication that we can easily distribute. And this one is in fact not running out of the box in a web environment. However, we implemented a plugin interface, and maybe you noticed when I picked up the Azure Communication Prefab, it was in a subfolder for plugins. And you can do similarly also with MQTT libraries that support web-based communication. And let me share my screen real quick to show you what you could do. We couldn't distribute this one because the plugin that we developed for also the building demo that is running on Unity Play, because it's a WebGL application, we used the paid asset from Rockworks, which is an MQTT communication that is also able to run in a web environment. And for this one, we used this plugin interface where we said on a high level, we still have the same broker system where you have the MQTT message provider, but in this case we replace the default MQTT library with a custom one, which is the simple MQTT. You can get it from the asset store, but you could also easily choose your own one and add this to the communication inside Unity. So basically all you need to do is hook up the MQTT message provider to make sure that whatever you use as MQTT library is sending the messages internally through the device systems. So, and then you are also able to run the demo as we do on Unity Play in a web environment, for example. So this is possible. And then there was another question regarding the key value mapping. And for the simple demo where we show the values here, like the occupancy and also the heating type, we pre-set up the user interface, just because we didn't spend too much time on creating a sophisticated user interface, but in fact you can, based on the incoming key value pair, easily dynamically create new field entries and also assign icons or create different kind of visualizations instead of just showing text items. And then Jack, there is a question, maybe this one is more towards you regarding the building model itself.
Yeah.
It's if this building data is derived from a BIM system like Revit or similar.
This one actually was made using Pro Builder because the model of our office in Brighton was just put together by one of the teams, but there's no harm in using Revit because you can also then add specific metadata that you could then link up by code automatically. So that format that Daniel had set up, the naming convention, you could add that name convention actually in your Revit model or other software similar, it doesn't have to be Revit, to then connect it by name. And you could even take it further, you could do it by GUID and other items if it gets into the thousands of devices in the good future. But yeah, not a problem. I did see a question in the chat side. How was AI used to code Unity? So, well, there's two methods. One, we have an internal system which I can add with files, which is really handy. It's using one of the standard AI services that anybody can access. But two, in Unity 6.2 using the beta, it's currently free to use AI that's in the actual product now. And that's quite different because it understands the context of your project. So give that a go because it'll understand the scripts that are already in there, but then also what you're trying to do to manipulate them. So jump in there. And even when it's fully released, Unity 6.2, there will be an allowance for all different license types. So obviously, if you've got paid licenses, you'll get a big bucket of access. Those details will be confirmed when we do launch. But even on personal edition at home, obviously give it a go. It's one way to focus on what you're trying to make and not how to make it sometimes, like me.
Very interesting.
And then what was
There's
the
a
other
question regarding bidirectional communication for Azure, since you showed this for MQTT, and in fact it's possible. However, there is a slight difference. When we get the device or basically linked to the IoT Hub, we just talk to the generic IoT endpoint, where we can get all device information. When we want to talk to or do this way back from Unity to Azure, we actually talk to the individual device. And if I pick the simple IoT device, you will see down here there's a connection string. So there you would actually use this connection string, and then you would be able to talk directly to the IoT device, similar to what we did in this Python script. If I find it in here, where we basically say our connection string is the device string, and that allows us to talk directly to the device. In this case, it's outside of Unity, but you could do this easily also inside Unity. So there is no constraint regarding the communication from Unity back to Azure.
So there's also a question in there about you've obviously shown Azure about potentially using it with AWS and other similar ones. You got any comments on that?
Absolutely. It would work the same. It's also on our table as one of the next updates, also showing you how to do the same with the AWS service, or even do a REST-based communication where you set up a simple REST client that is able to get data from another way of connecting to IoT devices.
Like if you know no code, what you can do is take a look at what Daniel's already done and probably make your own version out for AWS as well, because it's going to be fairly similar on the connection structure, authentication, and then communication. So obviously we are definitely looking at doing some more updates, and those are two good things that we might add as well. There's another question here around could you bring in CFD from ANSYS and OpenFOAM or something through in this way? I would say VFX graphics, probably how to represent that kind of information. A bit like you saw with the jacket, that was actually like particles, not actually a mesh object that was moving around. It's one of the samples that we give out. But in terms of reading the information, I'm not too sure whether those two software packages send that kind of data as telemetry. I know you can export as like a CSV, Excel, or some other kind of text-based format. But yeah, I'm not too sure. I'm not a big user of it myself. Don't know about Daniel, if you know any different on those two. What's your experience?
No, so I don't have any experience with ANSYS to get in the data, but I know the MQTT-based communication is used to talk, for example, to MATLAB Simulink. This is what we see in the simulation domain quite often, where you have the physics-based simulation running in Unity, but the behavior model of the machinery, could be an excavator or some other kind of machinery, is actually represented in MATLAB Simulink, and there the MQTT interface is also used quite often, but there are also other ways. Could be like a simple UDP connector. Yeah. Generally speaking, we had this topic of mapping the simulation results onto the 3D representation in Unity, but this was mostly done using vertex coloring, for example, where you read in the simulation result and then recolor the object. So it's not actually done using the MQTT system.
There's another question here around, does this fall under industry category? So for doing POCs, proof of concepts, do we require Unity industry? Well, this thing is based on where you're using it. If you want to try this at home, we have a personal license. Go ahead, make one, use your personal email, take it home, play as heart's content. It's all good. If you're a small company, we still have a personal edition for you to use. So go ahead. Again, even though you're industry and you're under the thresholds, $200,000 as a company, personal's you, and then up to $1 million as a revenue as a company. There is a pro license, just the same as the gamers use as well. And then if you're making lots of money and your company's making over $1 million turnover, yes, the industry license applies whether you're doing IoT or any other kind of Unity activity. Those are the rules of Unity, basically. But if you want to use it at home, hook up your personal email rather than work, and obviously use it for personal projects. So hobbyists and everybody that might watch this video, that's why I showed Home Assistant as well. Take it home. We want more of you to learn Unity, and then if you have a good reason to take it to work, obviously get a license for work. It's fine and valid. Other ones, let's have a look. This concept is called digital twin, right? So a digital twin, it can come in many forms. So a digital twin could be just a CAD model. It's a digital representation of something, be it building, machine, car, plane, whatever it may be. We made this operational by reading sensors that could be live in a building or a machine. So we made it operational. So it's bringing the digital twin to the next level. And then, as you'll see with probably other web casts that we do around AI, we try and make it prescriptive and all those other amazing use cases of digital twin that will make everything further smart in the future. But a basic foundation was IoT because that's the data that we want to link with the model representation and the user experience of an application that could control it. So ultimately with the bidirectional thing is you could have rules in there that when it gets too hot like it is in my room, I like it to turn on the air conditioning if I ever had any, or turn the blinds, or do something that's proactive in that space to make that building more smart, link devices together and not for them to just work in isolation. So, but I think all the technology is here. It's a case of putting the experience together, and that's what Unity is really good at. And you could use this on tablets, phones, etc. There was another good question in here as well. Let me just have a look about security. So, well, you've shown us giving our passwords away, but all of them are on our local based things, so you can access them anyway. I'd say for a proper industrial scale use, this is where the services from Microsoft, AWS, Siemens have one. There's many out there that have that security in mind, and this is why we did plug in for the IoT Hub, because that we put the security on their service. Yeah, we're just receiving it by obviously authentication. So you could also log in with single sign-on to secure it even further in your application. So that's how security can be obviously enhanced, is use a proper web service like those. And which cloud service have we used? Well, we used IoT Hub. You can get access for free because that's what Daniel's using. Hive, again, there is limited access for free as well. Home Assistant, completely free. It's only when you start using these things in higher numbers that these services have some sort of charge for them, or at least on the secured ones. So to get going, you can set up, your own accounts, plug in, get it going. Definitely not a problem. Any other questions, Daniel, spotting?
No, I just want maybe to add to this security related question. So even the open source M2 MQTT library supports SSL protocol. So this gives you already a good starting point. And with the Hive MQ, you could even go a step further and create a certificate that you can ship with the Unity application to really make sure that the client is allowed to talk to the system.
Fabulous. Good. How are we doing, Raoul? I know we're at time.
Good, yeah. Yeah, right on time. Very good. Great. Well, yeah, thanks for that. That was really interesting. Seems like I hope that was valuable to everyone in the audience. They definitely seem engaged. So yeah, we hope you get to use it soon.
It's there now. Download it today. That's the good thing. It's been available since last week. So give it a go. Love you to try it.
Cool, great. Well, thanks guys for that. And thank you everyone who joined. And yeah, happy using.
Wonderful. Okay.
See you later.
See you again. Bye for now.